Okay, this is question number 10. We've been given that the radius of the circle is 21 cm and angle HOK is equal to 40 degrees. We are asked to find the area of the sector HOK. Now let me draw the figure so that you will have a better understanding. Okay, we got the circle there, the center O, and we have the sector. This is H, this is K, there is a chord there, and this chord is shaded, and this angle is 40 degrees, this is 21 cm. Now sector area, in this case HOK, is given by theta over 360 times pi times r squared. So the theta is 40 degrees divided by 360, and r is 21 units, so it's going to be 21 squared. So 40 it cancels the zeros, 4 divides here 9 times, so you have 21 times 21 times pi divided by 9. 3 divides here 3 times, 3 divides here 7 times, 3 divides here 7 times, 7 into 7, 49, you have a pi. And since you are dealing with area, it's square units. Pi has 3.14, and you can multiply the value. So 3.14 multiplied with 49, you are getting a value of 153.86. Now you can write that as 154. Since the radius is given as cm, so this is going to be cm squared. So that's a solution. Now the next question is, they want us to find the area of triangle HOK. Now we know this formula. What is it? Area of triangle, say let me draw the sign. HOK is half times A into B into sine theta. Now A and B are given as 21 and theta is given as 40. So this is going to be half times 21 multiplied with 21 times sine of 40. Now take a calculator and type sine 40. What do you get? You're getting a value of 0.6428. Now that multiplied with 21, it's again multiplied with 21 and divided by 2. So this is giving you a value of 141.73 cm squared. So this is the area of triangle HOK. Okay, so now we are asked to find the area of the shaded region. Area of the shaded region. Now this is nothing but the area of the sector, and from the area of the sector you subtract the area of the triangle HOK. So in this case it's HOK sector. So area of the sector is 154, area of the triangle is 141.73. So 154, take away 141.73. So you get 12.27 cm squared. So this is the sector area, or I would say area of the shaded region. Okay, so that completes the solution of this question. Now this is the next question. Now we need to have a circle here. So let me draw the circle. Okay, so the circle is drawn, and there's a tangent here, but foremost let me draw the chords. Okay, fair enough. And this is actually being extended. And we have a tangent line there. Okay. So this is A, T, E, D. You need one more connection. Oh, this is 72. This is C. This is B. Okay. So now we are asked to, so this is given AOD 72 degrees. This is given. We are asked to find angle ADC, angle ACD, and angle CAD, angle OEA. So we need all of these. Okay, now foremost, you see here, this is the radius of the circle. OA is equal to OD is equal to radius of circle. So this means triangle AOD is an isosceles triangle. Okay, so this means the sum of A added with sum of O added with sum of D is 180 degrees. So angle A is going to be 180 degrees negative 72 degrees. I'll explain to you why. So from 10 you take away 2, you get 8. So 108 degrees. Now you are getting this to be as 108 degrees. Now actually speaking, this is going to be 2 times of angle A. Now why do I say 2 times of angle A? Is because angle A is actually equal to angle D. Why? Because it is an isosceles triangle, and that is the reason we need to have this 2 here. So this is equal to 108 degrees divided by 2. This is going to give me angle A, which is nothing but 54 degrees. So this in turn would means angle D is also equal to 54 degrees. So this angle is 54 degrees. This angle is 54 degrees. Okay, I hope you are getting the point. Okay, all right. Now, what is required here? ADC, CAD. Okay, so we have got CAD. So that one is done. CAD is got. Okay, C is here, and you got A, and this is leading to D. Well, we have an issue here because we have not completely got this angle. Okay, but it doesn't matter. Why it doesn't matter? Because we are only dealing with A here. So CAD is already got. So CAD is going to be 54 degrees. Okay, now having got that, now watch here, this entire line is going to be 180 degrees. Right, so I can actually get COD. So angle C, I hope you're watching here, angle COD is going to be equal to 180 degrees negative 72, which is going to be 108 degrees. So this angle, okay, is going to be 108 degrees. So angle COD is 108 degrees. Now, since we already know that this is a radius, this is also going to be the radius. So it's an isosceles triangle. Okay, so I can write that since triangle COD is an isosceles triangle, this means OC is equal to OD, which is equal to R. So this in turn means if I want to get this distance, or I would say this angle or this angle, I can clearly state that this means angle C plus angle D plus angle at O, sum of the angle is 180 degrees, but angle at O is 108 degrees, right? 108 degrees. Now since angle at C and angle at D are going to be same, I can write this as 2 times angle C is equal to 180 degrees. So therefore 2 times angle C is equal to 180 minus 108, and that is going to be 72, right? 72 degrees is angle C, you need to divide by 2. So that's going to be 2 divides 7, 3 times, carry 1, 36 degrees. So this means angle D will also be 36 degrees. Okay, so this is 36 degrees and this is 36 degrees. Now this, both of them are 36 degrees. So that means angle at D, the total angle is going to be what? 36, or I would say that this is 36 and this is 54 degrees. Okay, so this is going, you add up these two things, you get 90 degrees. And clearly the angle inside the semicircle is 90 degrees. One of the angles inside the semicircle is going to be 90 degrees, and that means we are on the right track. Okay, so this entire thing is going to be 90 degrees because of the property of the semicircle geometry, and that is exactly what we are getting here. But having mentioned that, let us go back and find the other requirements. We are asked to find ADC. So ADC, okay. So what is ADC? ADC, see this total angle they are asking, ADC. What is that? Just know we just got it as 90 degrees. So ADC is got 90 degrees. Okay, now we have to go and get ACD. ACD is also got. What's your ACD? What is that? 36 degrees. Even that is got. Now OEA. Now we need to get OEA. Now do you know what is this angle? This entire angle. This entire angle is nothing but this is the tangent and this is the radius. According to tangent theorem, the radius makes an angle of 90 degrees with a tangent. So this entire thing is going to be 90. This entire thing is going to be 90. So from 90 you take away 54, what do you get? 10. From 10 you take away 4, you get 6. From 8, so this is 36 degrees. This angle is 36 degrees. But is that what is required? do we need that? Now you just see here, actually we can directly get the value of angle E, because what do we have here? AOD. Okay, so this corner angle is already, we already have the details of this corner angle, right? Isn't it? So it is 72 degrees. So I need to add 90, because I know that this entire angle is 90. This plus 72, that's going to be 162. And all we need to do is to get this angle E, take 162 from 180 degrees. So I'm just going to state it here. So angle E is got by taking out 162 from 180. So how much would that be? So from 180 I take away 162, 18 degrees. So this is going to be 18 degrees. Okay, so let me write this down, 18 degrees. Okay, so we have got all of these values that are required in the question. So that completes the solution. So we move on to the next one.